Hey guys, welcome to Code Decode. Today we are going to start with concurrent collection interview questions. So let's get started. So the very first question is, if you had collections already, why in Java 1.5 we had a need of concurrent collections? The traditional collections were not thread safe. Even there were some thread safe classes like vector hash tables, but these were legacy classes. Now you can also convert your list, array list, map, set into synchronized ones, but the problem with them is they decreases the performance, though they provide you the thread safety. And the third problem was that in traditional collection, if one thread iterates and tries to modify the structural change in any of the list, map, hash set, any of those, then concurrent modification exception was thrown. I'll give you an example of it. So this was my hash map. Okay, in hash map I'm going to put my key value pair. So my key is also 1, value is also 1. Now I have three elements 1, 2 and 3 with the value of 1, 2 and 3 simultaneously. I have an iterator which iterates over the key set. I am going to start an iterator and hence I'll get an iterator instance. Now I'm checking whether the iterator has some next values. It has, please give me the next value. So at the first iteration 1 will be the key, and then if you try to get map.get 1, the value will be 1 only, and hence you can print as 1 and 1. Now if it checks if key is equal to 2, no, my key is 1, so it doesn't do any modification. See the line number 17. This line says map.put 4,4. This is a structural change. If you can see, initially my map was only of size 3. With this particular line of code, that is 17, my map will become the size of 4. So this is the structural change that I'm talking about. So if you try to modify the structural change, then concurrent modification exception is thrown. Now in the second iteration, my key becomes 2 and the value is also 2. So you will be able to print 1, 1, 2, 2, but the if condition says if 2 is equal to 2, initiate the another row with 4, 4, which increases the size of a map, and hence there's a structural change basically. In this particular scenario, you will get concurrent modification exception. If I try to run this for you, you will see my map 1, 2 is printed, but simultaneously I get concurrent modification exception, if you can see this. So this is the problem. We used to have concurrent modification exception if you try to make some structural change, and hence what came into rescue is from Java 1.5 is a concurrent collection. So concurrent part of HashMap is ConcurrentHashMap. So let's see if ConcurrentHashMap helps us in this. Now I'm changing my HashMap to ConcurrentHashMap, and I'm just wishing that I should be able to retrieve all the key value pair, and simultaneously I should be able to put also. So if I try to run it, I should get 4 rows. 1, 2, 3 and 4. So this is the beauty of concurrent collections for you, which was introduced in Java 1.5. Few example of concurrent classes in Java 1.5 were concurrent hash map, copy on write array list, and copy on write array set. We'll see all of these in detail now. Now the question that will be asked is, if you have hash table or the synchronized map, why is performance good with concurrent hash map? You said that your performance is decreased because of hash table and synchronized map. How is it increased in concurrent hash map? So that's a very important question. In hash table or the synchronized map, the lock is acquired on the complete collection. So only a single thread can capture lock of the whole object of concurrent hash map. So basically what it means is, I'll show it diagrammatically so that you can understand it better. So this is my hash table, okay? So what used to happen was, suppose I have few buckets here. Say suppose 16 buckets were there. So it will be counted from 0, 1, 2, 3 and so on till 15. This is my hash table. It can be your hash table or it can be your synchronized map. In both the cases, what happens is, this is legacy one, this is the synchronized version of your collection. What happens is, if there comes my T1 thread and it says update a row, then what happens is, if you want to update the value at first bucket, that is 2, 2, and I have to make it to 3, 3. In that particular case, you have the write operation. If you are doing to write or update this, the lock will be taken on the whole of the hash table, and hence the performance decreases, because now if T2 comes and says, okay, just let me read what the key value pair is at bucket number 15 or bucket number 14. you won't be able to do that also. It says that I'm just going to read it, I'm not going to write anything, just let me read. But you are not allowed to do that also, because lock is taken by T1. Though it is updating just one bucket, you are not allowed to read at the very bottom bucket also. So that's the performance issue that is actually solved by the concurrent hash map for you.
We have heard a lot from our fresher friends that when they start giving job interviews, the first company who offered the job becomes their showstopper. Our biggest regrets in the life are the choices we didn't make, and for sure it will include you missing out on your dream job just because you were afraid to move out of the first company who offered you your first job. Why do you want to compromise on your career that has barely even started? It may be because you are too scared to lose out the current opportunity, or you just have the fear of rejection. So here comes the rescue, that is Relevel from Unacademy, that gives you an option. Now all you have to do is believe in your Relevel score. Through Relevel you don't have to apply to companies, your Relevel score will speak for you. And the best part is it is completely free, and your dream company will come back to you with the potential offers. All of this will be incentive, brand value, higher pay and streamlined job profile. So please don't take the first job that you get. Try and join Relevel today and get access to all the opportunities that you would have missed out, and that too completely free.
There is something called as concurrency level in concurrent hash map. Now you'll ask me, what is concurrency level? So concurrency level defines how many threads are allowed to get a lock. As by default, the concurrent hash map has 16 buckets, and concurrency level also has 16 value. So by default, that means your 16 threads can simultaneously lock a bucket at each time. So okay, too much of theory. Let me explain it with an example. There is something called as concurrency level. So this is my hash table again, and I have 15 buckets. Okay, similar to 0, 1, 2, 3 until 15. Now you have 16 buckets starting from index 0 to 15. You have 16 buckets in total. Now concurrency level is how many threads are allowed to simultaneously use your bucket. So currently my basically concurrency level is 16, and the default size or the bucket size of HashMap is also 16. So bucket is also 16. So concurrency level says that, so it says 16 by 16 says as 1, that is the number of buckets held by one segment. And even on this you can have an array list. So there is one entry map, there is another entry map, there is third entry map. All these 3 entry maps, the list of this entry map or the balance tree of this entry map will comes under this S0, that is segment 0. So this is the concurrency level. So the concurrency level is how many threads are allowed to get a lock. So basically there are 16 segments and 16 threads can work on 16 buckets here. Now what if I change my concurrency level to 8? So it says now my concurrency level is changed to 8. So again, this is my hash table, and now this is my 16 buckets, 0, 1, 2 and so on till 15. But my concurrency level is now 8 and buckets are 16. So my segment size will be 16 divided by 8, which is nothing but 2. So 2 buckets will be handled by one segment. Again 2 buckets will be handled by the second segment, and so on. 14th and 15th will be handled by 8th segment or S7th. There are 8 segments. So this is how you decide the segmentations and the number of buckets handled using the concurrency level. So if you can understand, the number of buckets and the concurrency level decides how many segments your whole hash table will have, and when you change your concurrency level, the buckets in each single segment having the lock property will also change. So do you understand the concurrency level? I understand this is critical and this is complex to understand. If you're not able to understand, just let me know in the comment section. I'll create a separate video on just concurrency, the segmentations and the concurrent hash maps. Now, can multiple thread read simultaneously from concurrent hash map? Answer is read does not need any lock, and hence you can read multiple. So now this whole segment, if I say I need to read from bucket number 0 T1. So T1 thread is reading from bucket number 0, T2 is reading from bucket number 3. So it doesn't say any issue. There is no concurrent modification exception because modification is not just happening. So basically read does not need any lock. You don't need anything on this front. There is no issue when multiple threads are trying to read from it. Can multiple threads read and write simultaneously? No, the write operation needs a lock. So if T1 is writing on the 0th bucket, T2 cannot do anything on 0 or 1 because the segment lock is taken. So this is my hash table, suppose in a horizontal way. You have these many buckets till S15 and you have concurrency level of 8. So basically two buckets in one segment. So now the segment 0 is going to have your lock. 0 and 1 comes under same segment lock. So if T1 is writing on 0 or 1, none of the thread can write or read from 0 or 1. You have all the rest of the buckets available and segments available. Go and read from there, go and write from there, not from 0 or 1. Now if suppose I had just 16 as the concurrency level and similarly 16 as the bucket number, then only one segment is having one bucket. So if T1 is writing on 0, T2 can happily write on S1 because segment lock is taken. T1 has taken the segment lock, but segment lock S1 is still not taken. So T2 can go ahead and write to segment 1. That is why concurrency is so important to understand about. Okay, if that much is clear, a very important question, why nulls are not allowed in concurrent hash map and why it is allowed in hash map. A very simple example to that. So I'll give you a code example of it. Okay, if concurrent hash map contain a key, return the value of that particular key. Now suppose T1 and T2 are the two threads running this line of code. If T1 runs this condition and check if key is present, it goes and try to fetch in the next line. So this is suppose line number 1, this is line number 2. So T1 checks, is my key 1 present in hash map? It says yes. But before it goes and fetches the value stored at key 1, suppose T2 also came here and deleted the key 1. Now if the key is not present, the return of this get key of 1 will be null. Now null can come in two situations. If 1 has null stored, which is not in our case, it had some value. Here the case was key was not there in the map at all because the key value pair is removed by T2. Null will be returned. So this is ambiguity. When you get null in concurrent hash map, you won't know whether the value is null or even there can be a case another thread came in picture when I try to read whether key is present, and between I try to get it, there is one thread in between this line who deleted my key and value, and so there can also be a null. So there is ambiguity and hence null is not allowed. If it is still not understood to you, please let me know in the comment section. I'll create a program out of it and I'll show you each line by line debugging what can happen during the concurrent modification exception. Then only I'll show that to you. Otherwise, I believe this is understandable. A very important point, what is the internal working of concurrent hash map? Now, we have known what is concurrency level. Concurrency level is basically default by 16 and hence your concurrent hash map is divided into 16 segments. Each segment acts as an independent hash table. During the write operation, the lock is obtained on a particular segment and not on the entire hash map. I think I've already made you understood this, that what is concurrency level I told you. If it is divided into 16, each segment is a standalone bucket. You can consider this as a standalone hash table and anybody can work upon it. If it would have been two buckets in one segment, what would have been there? 0, 1 till 15. So my concurrency level is 8, bucket is 16, two segments, two buckets in one segment, 0 and 1 bucket in one segment. Then it will be divided into 8 segments and each segment will be acting as a standalone hash table. And hence multiple segment lock can be taken. This locking mechanism can be called as two things. First is rearranged lock or second strip locking or locking strip. That is the mechanism you do. You lock your strippings. So basically each segment getting lock on n number of buckets is strip locking. Hence, two threads operating on different segments can acquire lock on those segments without interfering with each other and proceed simultaneously as they work on separate segments. A very important point to note here while you explain concurrent hash map is the operations, that is read, write and update operations. So basically read or get operations, what are the scenarios here? If two thread T1 and T2 are reading from same or different segment sections, then there will be non-blocking operation. So you will be asked in interview what is blocking operation and when does your concurrent hash map shows the blocking operation. So in HashTable, even one thread working on any of these bucket will have a blocking operation, which is not in the case of concurrent hash map. In concurrent hash map, if you are reading, no blocking. If you are trying to write, so T1 and T2 is writing on different segment at the same time, then no problem, there is no blocking. So this is my segment S0, this is my segment S1. Now I have two threads working on different segments. So T1 is working on segment bucket 0, segment 0. Now T2 is working on bucket 3, segment 1. So these are different segments, so no blocking operation. But two threads can't read on same segment at same time. So if T1 after updating this, T2 comes here and says, okay, I want to update bucket 1 that is in segment 0. T1 says, no, I have lock on bucket 0 segment 0. So basically I've taken, if I'm working on bucket 0, I've taken a lock of segment 0. You cannot come and update anything which comes under segment 0. Any bucket which comes under segment 0. So T2 says, no, my one bucket comes under segment 0. So I have to wait until T1 releases the lock. So basically two threads cannot write on same data. It's a blocking operation. Read and write operation. Two thread can read and write on different segment at the same time without blocking. So this is already clear. You can read from anywhere. That's not a problem. It's completely non-blocking. Segment doesn't even matter. When segment comes into and locking comes into picture is when you are trying to update or write. So you can update or write on a different segment, no problem. Just do not try to get a lock on the segment which is already being locked. You will have to wait for it. Okay, so if this is clear, you have two more operations apart from just reading and writing, that is put and get. So whenever you have to put some values, so we have seen this is put operation and this is get operation. This is get operation. So in concurrent hash map also has put and get operation. When you try to put a particular key value pair, so I'll show this to you. Now I'm trying to put at bucket number 0, I'm trying to put 1, 1. In this particular case, you are trying to put something, right? So thread T1 will get a lock on segment 0. But before that, what you need to calculate is the segment index. So basically segment index is S0. Then this segment has two buckets, 0 and 1. So based on the hash code of 1, the bucket number 0 is calculated. And when you have the segment index and hash index, now you can happily go and put your 1, 1 on this bucket 0, segment 0. Now if you want to put something like 2, 2 on segment on bucket 1, then again your segment remains segment 0. Your bucket number changes from 0 to 1. So now here you can put it. So first find the segment and then find the hash code of the key, that is nothing but the hash code or the bucket number where on the table you need to put it. So now you have an overhead. You just not have to calculate the hash code. You need to get the hash segment index also. Now how does get operation works? Similarly, if I just want to have get 2. So the 2 is stored in at the first bucket on segment 0. So first calculate the segment number, then calculate the hash code, and then on that particular bucket go and find your value. So based on segment index, figure out the segment, then based on hash code, figure out the bucket number and get the value from the array inside the segment. It is similar to the one done in HashMap. So basically we have done everything which we would have covered in concurrent HashMap. Okay. Now a very important part that is array list and copy on write array list, but time doesn't permit me, so I think we need to close this. Before that, I'll show you one example that how array list and HashMap and concurrent HashMap differs in the mod counts. So basically there is something called as mod count, which calculates the size or the bucket size of your hash code. So there is some expected mod count. So suppose I have 3 buckets here, that is having 1, 2 and 3. Now if I try to add something, then the size of the hash map increases. So in this particular case, my mod count becomes 4 and expected mod count was 3, and hence concurrent modification exception was thrown. Now this whole case was removed in concurrent hash map. Concurrent hash map completely works upon segment shifts and masks. Basically you calculate your segment index and you put your data onto it. So basically when you try to write, a segment is first found, and then you write your object onto that particular segment and on that particular hashed code. So basically if you try to go into hash and find mod count, you won't find it, string not found, but in hash this mod count was present. So that is why concurrent hash map doesn't throw any kind of concurrent modification exception, while hash map does. If this is clear, I have similar thing for the array list. Just let me know in the comment section if you want me to cover this also, then only I'll create another part of it. Thank you.